Hi everyone. In this section, we'll be going through questions such as these here. Alright? Find the smallest integer k such that 126k is a perfect square. Let me transfer the question first. First thing to take note is that you need to understand what is a perfect square, right? Definition of perfect square in terms of prime factorization is that the powers are all divisible by 2. Okay, so we set up our board right on 1 to 6. First of all, we also have to find our prime factorization for 1 to 6. So let's do it quickly here. Use the ladder method. 1 to 6 divided by 2, you get 63. Divided by 3, you get 21. You get 3 again. You get 7. 7, 1. So we know that 1 to 6 equals to 2 times 3 square times 7. And here what you do for the working is you put a k here, long line, and after that you put 126k. The goal is to make 126k a perfect square by which all the powers are divisible by 2. You also need to understand the relationship between 126k. If it's a multiplication, right, you have to power up. Power up. So over here is 2 power 1 and 7 power 1. So this is not a multiple of 2 yet. This is not a multiple of 2 yet. We have to make them a multiple of 2. So what do? You power them up. 2 power 1 becomes a 2 square. 3 square is already a multiple of 2, so you don't have to touch that. You just copy it down. 3 squared. And 7 has to be powered up because only 7 or 1. So 7 power 2. So look at this column here. How from 2 power 1 to get to 2 power 2? And you want to multiply it by something, so it's 2 power 1. So if you take 2 power 1 times 2 power 1, it gives you 2 squared. Next, of course, same thing for the 7. For the 7 power 1, because 7 power 1 sometimes 7 power 1, it gives you 7 squared. And this results you in having a perfect square. So what is our k? K is just 2 times 7, which gives you 14. You can try it out. 126 times 14, when you square it, it should give you a nice answer. Right? That's all. Thank you so much.